thank you all for joining in this wonderful session. We are very fortunate to have Ben be our speaker. He will be Ben from GoGuardian. He's the lead data scientist there. He'll be speaking to us about 3 agents. And take it away, Ben.
Thank you so much. Really excited to be here. PyData Boston, woohoo. So this talk is kind of me putting together some of the explorations that I've done with some of the different agent frameworks. I'm using that word a little bit fuzzy. I had a whole note about frameworks as in terminology, whatever. I'm looking at 3 different implementations of agents. And I think this talk is basically a process that I explored to sort of understand the different workflows that go into that, the different design decisions. I don't know if folks attended Sebastian's talk yesterday. I thought, call out to that because I think it was a great lead in because it sort of sets up the kind of workflows that exist around agents, and now we can sort of see how those workflows are kind of implemented in 3 different ways. I know the description says something about LlamaBot. We're not going to be doing LlamaBot. We're going to be doing it a different way, but we'll see. This is just about me. So I've been in data science for a decade. I've worked mainly in language technology, and it's awesome to see much more interest in language technology now. But we can talk about what that means with so much more people in the area. I work at GoGuardian, which is a platform for K through 12 schools, doing a lot of monitoring, traffic, categorization, filtering, things like that. I'm happy to talk about that if you're interested, but I've been around the block a bit. So this talk, I'm going to describe kind of briefly the components of an AI agent. I'm assuming people have kind of been exposed to that to some extent. Actually, folks are reasonably comfortable with what are the components of an AI agent. I'll tune mine. Okay, generally, okay. There's been a lot of agents this conference. So I'm going to introduce 3 implementations, actual code in a 40-minute thing. We'll see how that works. And then we'll discuss. I'll try to have a little bit of a discussion with what time we have. I'm not going to give an introduction to LLMs, but if you want one, I've done that. I'm not going to go full coverage on each framework's features. I know LangChain and Pydantic have a ton of features, and I'm not diving deep in them, not just because I haven't actually explored them, but because it's huge and ever-changing. I'm just going to sort of be very surface about this, and I'm not going to tell you what's the best framework, because I don't think there is an answer to that question. So I will do my own little spin on what is an agent, and I won't spend too much time because I think a lot of people have covered this actually better. But Anthropic's definition I think is pretty good, where it's essentially focused on that kind of autonomy to some extent, the ability to choose the actions that the system's going to take. I think that's the agentic part of it, and you can sort of think. I sort of laid these 3 out. I took this from or adapted this from the LangChain blog. But you can think in code, you are sort of determining kind of all the different steps, or your code is determining all the different steps. When you're just doing an LM call, the LM call is deciding what the output is going to be. That's where it sort of has its flexibility, but you're sort of directing what it's going to have as input and what that output, where that output will sit. With an agent, it sort of decides a little bit of what steps to take. We can discuss this part. I still think that you are involved in deciding what steps it has the options of taking, but that's actually, we can discuss that at some point. Components of an agent, I like this diagram just because it's simple. I think the core pieces are here, where you have to have some sort of memory. It has to have some idea of what it's done so far. It has to have some actions that it can take. And planning is a little bit of a fuzzier one, because I think it's sort of a derivative sort of thing. You can think of planning as simple as it's a chain of thought. Ask the model to lay out its steps, but it can also be more complex, which sort of requires the actions and the memory to some extent, and planning is essentially laying that out in a way that makes sense that it can get to an answer. But then there's the agent core, which is an LLM and probably some input and output processing on either end of that. So we're going to be talking about LangChain and Pydantic.AI. I'm also going to have a kind of from scratch implementation just using Llama's Python library, but I think it's always useful. I had my undergrad was in history, and I like understanding history, and so I dug in a little bit to the history of these different libraries to understand what their worldview is. And so LangChain came out very early, super early mover in this space. I think they said that they released, and then a month later, ChatGPT happened. So it's it was there at the beginning. In 2023, a lot of things changed. They released a lot more libraries, packages, some of them open source, some of them closed source. They came up with this idea of this pipeline that you can sort of build workflows around different processing steps. which I think is pretty interesting, though that sort of moved into graphs now, like how things like interact with each other in some sort of way. And I won't dig too much into that, but LangGraph kind of brings that to the fore. So like basically 2 months ago, LangChain v1 just kind of moved all of the previous LangChain to another package called LangChain Core. And now LangChain is essentially this abstraction on top of LangChain Graph. LangChain Graph is a lower level kind of way of building these graphs, and LangChain does a lot of abstraction on top of that. LangChain's philosophy, from their docs, they want to be the easiest place to build an LLM, also be flexible, also be production ready. I think that sort of captures a little bit of like what they are, where they try to do all of the things, and that's awesome in some ways, but also is like a little bit of a weakness in some ways because they change a lot to like accommodate all that capability. V1 seems like they're trying to standardize things a little bit, wrap everything that's high level into LangChain, and put everything that's lower level into LangGraph. They have a number of different dependencies. This is sort of getting at what I was saying before, that because they want to integrate with everything, they have a number of different like libraries. So if you want to interact with Anthropic, you have to have LangChain Anthropic. Oh my gosh, that's a hard word to say. LangChain, Llama, et cetera. LangChain Core has a lot of some of the older approaches that you'll see in a lot of tutorials and things like that. This is just an example of like that comes from their docs, like a basically hello world kind of thing. Now Pydantic. Now I give the history of Pydantic like generally as a library because Pydantic.AI is very new. But Pydantic is very like well established and well respected as a sort of data data model validation library. It's used basically by a lot of the agent frameworks underneath the hood, and well respected, et cetera, in that field. Yeah, so there's a large-scale refactoring that happened recently, and then it was 2024 that Pydantic.AI was released. Their logic was essentially everybody's using us under the hood as the data validation, and data validation is like a major part of like building these workflows. So why don't we just like add workflows on top of our kind of validation structure, and then essentially we have an AI agent framework. Their philosophy from the docs is essentially that fast API feeling to Gen AI app and agent development. And what did fast API bring? My understanding, and people like feel free to correct me if you have more experience with using fast API to build things, but essentially a lot of standardization, a lot of taking away kind of the boilerplate for setting up an API, and a lot of like the documentation kind of gets auto-generated from how you sort of set up the API. And I think that's like, it's a good description of what they're trying to do, where they're trying to essentially allow you to build an agent that's kind of like ready to go, right? You can take what you've built, and it should be relatively in a state that you could then start thinking about deploying the workflow. And so that's the deployment first thinking. And so everything is designed around async processing, and their logic for why async is so important to what they're doing is that a lot of with like agent applications, a lot of the time spent is waiting for your LLM to get back to you. And so you don't want to tie up the process with those sorts of, that sort of waiting. And so async makes sense in that way. And then of course the validation, like this is what Pydantic does best. It's the validation of the inputs, the outputs, and the model context, different components of the model context. So if you want to pass a database connection, you can specify that, and you can pass that along with the agent context. I had actually talked to the founder of like Pydantic, Sam Colvin, and he was like really all about like the ability to execute tools in or like code in a separate kind of environment, not in your like current like local or whatever. And he was all about like how no other framework does that. I'm not sure if he's quite right on that, but like he said that like that's an important thing to sort of call out, that we sort of just assume that the tool is going to run wherever it runs. That's not important. But that would be important depending on whether you want arbitrary code running in a particular environment. They also have a library called Logfire, which I think parts of it are open source, but most of it is closed source. But it's a nice implementation of evals and observability, and it's integrated with this library. And generally, they have all sort of the provider functionality kind of baked in to that library, so it's a nice all-in-one kind of package, less kind of a distributed set of dependencies. Cool. So then the other third implementation, and this is actually we're going to start, kind of did it in reverse order, but I kind of wanted to get close to a from scratch implementation. This was for my own exploration to kind of understand what's going on underneath the hood, see exactly what are the tokens that are being fed to the model and what is the model giving back, because that's just useful for me to understand like these different roles. Actually, sorry to just keep calling you out, Sebastian, but Sebastian's talk sort of laid out like these different turns and the different roles, and I think that was a really good way of like framing it, that there's different, like the model has been trained like underneath the hood, like fine-tuned to understand what these different roles do. Like a tool means something, a tool use means something, a user means something, a system means something. So this is why it's useful to kind of look at the actual things that are going to the model. So Ollama, for folks who are not familiar, it's essentially an open source platform for hosting local LLMs. The models are nicely packaged with like docs and prompt templates. Prompt templates look something like this, but are a lot longer and more complicated. It's sort of useful to see where the things that you are bringing to the table sort of slot in to what's going into the model. And we're just going to be using the Python library to interact with those models. Code time. Any questions before I just like jump into code? Quick questions. No? We're just going to do code then. And I'm going to try and make this work. Wrong direction. That direction. How does that look? Great. Cool. Okay, so we're going to start just with Ollama. We're going to initialize the model. We're going to be using Llama 3.1. So if you access the GitHub, there should be a setup for if you want to like run this on your own. But I'm just using Llama 3.1, and this is the 7 billion parameter small model, right? So it's not capable of a lot, but it's fine for this for these purposes. So we're just going to say hi to our model, right? That's the hello world kind of. Oops, I didn't actually import anything. Did I not import anything?
Can you make it a little bit bigger?
Sorry?
Can you make it a little bit?
Yes. Thank you for asking. Yeah, that's always a problem. Okay, maybe I already imported something. My bad. Okay, so then we just are printing the response. The response has a bunch of different components to it, but the main thing here is this content. So this is a response. Basic. If we actually looked at what was going into the model, this is what this would look like. These are the actual tokens that are going into the model. And so this is particularly for Llama 3.1. So there's other models have different templates, so it'll look a little different. I have an example at the bottom, but just so you know. Cool. And so this is the tool we're going to use. It's a dumb tool, super simple tool, but I just wanted to like say like this is a function that gets called right outside of the context, and so it does the job. So in this case, we're going to ask the model, what day is it today? We're going to specify that we have these tools available, and we'll see what the response. Anybody have a guess what the response of the model will be? Make it interactive.
Yeah. 2024.
Okay, 2024. What is the response? What do you think people will respond?
2021, is it?
10th of December. What's the tool definition?
Yeah.
Oh shoot, the tool definition is up here. Where is it? I lost it already. Here.
It's today's date.
Today's
if
date.
It calls on the tool, and some 2023 date if it doesn't.
So it's even simpler than that. You guys are jumping ahead. It's actually just calling the tool. So we didn't set up anything to actually execute the tool yet. Right now it's just saying, I want to call this tool, and we haven't set up any workflow around that, right? So it specifies this. This is like the Llama library, Python library happening underneath the hood, processing this. But if you want to look at what the model sees, like there's a lot, but the main thing is it's like gives us the information about the tool. So the model actually sees like, oh, here's what like I need to structure my output to be. So cool. This is just a way of calling that tool. Like I'm just putting it up here because we use it further down the line, but this will actually use the parameters of the model output to actually call the tool, and then it'll give today's date. That is today's date, right? Yeah, great. Cool. So then memory is another component that we sort of talked about. I'm going to implement memory in a pretty dumb way, which is just a list, and I'm just going to do 2 turns. That was the terminology. 2 turns here, where I'm going to tell the model my name is Ben, and then I'm going to ask it what my name is. And so if I just run this, you can see I'm passing to the chat the messages of the conversation history, so as a list. So both what I said before and the agent's response, and then I'm asking what my name is. And this is its response. So essentially, your name is Ben. So it remembered that. Now planning, I said, is kind of a little bit tricky, but essentially planning, I'm just taking those two components, the tool calling and the capacity for memory, and putting those two together and building an agent, quote unquote. Can we call it an agent? Sort of, not really, but we're just going to say that it is. So first we just do asking it what day it is today. It tells us I want to call this tool. And then we're going to execute the tool, and then we're going to pass the model the role tool and the actual content of the response, because that's what at least Llama 3.1 expects. Pass the conversation history, tool response, the actual tool, and then we get the response. Boom. And so this is the response here. This is the actual content. So it took the response from the tool and formatted it in a way that I could say, like, here's an answer. Cool. So does that all make sense? Yeah, and this is just, like, this is for Llama 3.1, the format, the template. Other models have different templates. So this is, so let's go back to the slides. Is that easy? Yes. So discuss. So what do people think about that approach? Have we built a nice model? Can we ship this to whatever, OpenAI, whatever it is?
Ship it.
Ship it. It's ready to go. Man, all right, talk done. Let's go.
It's pretty straightforward.
Yeah.
Straightforward and simple.
It's simple. Are there, like, downsides to it? Any issues that we see? Well, what's in it, like?
We'll see when it breaks.
Yeah, it'll eventually break, right? It will not scale. Like, right, this is not something that we could, like, ship, right? It's very customized to this this teaching example, right? But what's nice about it, right, is that we can see all the, like, pieces to it, right? We have full control. But honestly, we would probably want to abstract some of the controls so we don't have to, like, build every single thing around every single possible input. So that's sort of the point of an agent. So now we're going to switch to LangChain. Everybody loves LangChain, right? Do we have feelings about LangChain? Does the audience have feelings? We do have feelings. Okay, I want to see those feelings come out. Okay, so this is the same tool, but in this case we have a decorator from LangChain that basically gives LangChain what it needs in terms of, like, what are the parameters, what are the doc strings, etc. LangChain really likes this method called invoke to call a tool or call a chain. And evoke just does what you'd imagine it would do is just give us the result if you actually call the tool. So that's cool. So now we're going to actually create an agent, and look how easy that is. We essentially provide the tools, we initialize the model, and we create the agent with the model and the tools component. This is, like, the simplest possible thing. There's a lot more in create agent. There's a lot more you can put in there, but we're just going to make this basic. And so one of the nice things with LangChain, like like the first, like, whatever, V1, is that you have this get graph underneath the hood, and whatever, I'll take the time, even though I probably don't have the time. You get a nice mermaid diagram of the graph, which is pretty cool. Great. So now we're just going to do the same thing. We're going to ask it what day is it today, and it's going to do all of that work that we did in the previous notebook, essentially. Boom. Beautiful. Now, one thing, it sort of has memory to some extent, and so I won't spend too much time on this, but if, say, we wanted memory, like multi-turn memory, so we wanted to ask it now a question about what it just said, then we would use LangChain's, LangGraph's, like, checkpoints, and there's a bunch of different ways. You can have, like, a database, et cetera, or you can just have it in memory. This is kind of the simplest example that I could figure out to make it have multi-turn memory. And in this case, LangChain really likes you to have a configurable ID. So it's like a particular session has this, like, these things happening, and it can go through that session. I'm not going to spend too much time on this. This is just if you wanted to, just to sort of close the loop, like if you wanted to have multi-turn memory into it. There's a bunch of different ways of doing it, but, like, this is LangChain's sort of decision about that. Cool, we already built an agent. That was a quick one. Strengths, weaknesses, thoughts about that?
Simpler auto initialization and stuff, like their setup was easier.
Yeah, for sure, easier setup, right? We don't see everything that's happening underneath the hood, but it's, like, much simpler to set it up. Yeah.
I was going to say the same. Very fast to set up, but maybe some questions about how, like, hackable the result is. Because if you just call one line and everything gets done magically, how much customizability does that give you?
Yeah.
Which would be my question. I don't know if that's going to be true or not. But
No, I mean, you guys are like, playing right into my hands here, but it's, wait, sorry, I wanted to have one thing here. Okay. But yes, no, sort of exactly those things. It's complete, something I didn't even really call out, but it's model agnostic. You can sort of switch out what the provider is. You have the capability for observing steps. LangChain generally has a lot of community behind it. It's been around for a while. But everything's abstracted. LangChain generally has to pull in a lot of different things to have that LangChain Llama. I had to have a package called LangChain Llama to be able to use a Llama if I wanted OpenAI, same thing. Tools are all being executed locally. It does have the capacity to not do that, but you have to do a bunch of configuration. And by nature, it's not really doing any of the data validation to just make a difference between it and Pydantic.AI. And LangChain, if people have feelings around LangChain, probably are there because every update, they tend to break everything that came before. But that's not to say like LangChain is not powerful. It has a ton of integration, and it's the community that makes it powerful. That's the theme of today. So not like still a powerful library on its own. So let's switch over to Pydantic.AI. Fantastic, I'm good. All right. So this is Pydantic. So we have to apply a little patch. This is sort of, I want to call this out just because to use it in Jupyter Notebooks. Jupyter Notebooks has a bunch of async stuff happening behind the hood. So it needs that patch to be able to work effectively. Okay, so similar actual setup, right? Like speaking of boringly simple loops, it's the same kind of thing. We're creating a provider, an Llama. The Llama model is the model underneath the agent, and we're initializing the agent around that provider. In this case, this is how Pydantic.AI has implemented it. Llama accepts kind of the same format that the OpenAI SDK does, so you can just use like OpenAI chat model, but the provider is a Llama. And in this case, what Pydantic prefers is that the tool essentially be a component of the agent. So we're using a decorator, but the decorator is a module of the tool. And in this case, if you're just doing the base tool, you need to also account for the context that's going to be passing through the model workflow, and that's like the run context. And you can specify what things are contained in there, but it has to have that allowance for the context because that's how it's going to call the tool. So we define it, same sort of thing. And in this case, if I just print what happens when I just say agent run, it's the coroutine. If we wait for that to finish, we get the result, which is the result that we expect. I'm only calling that out because I feel like it's a little bit of a nuance versus other frameworks. It's like by nature async, and to even do the run sync, it's just a wrapper around the sync process. So just sometimes that makes it a little bit more difficult to debug if something goes wrong in there, just for me. Maybe as someone who's not super familiar with using async processes. But we get the right answer from here, and if we get all messages, we see everything that happened, all the different steps. So model request, model response, the tool return, and the actual result. Cool. Also calling out memory here, a little bit simpler implementation of memory, but it's also requires you to sort of manage that. It doesn't have this, it doesn't the check pointer is not required. You can just pass it essentially a message history when you do this run. So if I ask it, what did it just say, and I pass as a message history all the messages that came before, it says I previously stated that this was the date. So it has a multi-turn memory. So I'm not giving Pydantic its fair share. If you look at Pydantic's actual documentation, they say, create a data model for everything, the inputs, the outputs, the dependencies, all those sorts of things, which makes sense, right? If you want to have some expectations imposed on what the model output is, probably, especially if you have different steps in the pipeline, right? You want one step to output something that has, is in JSON format or something like that. So it makes sense to think about what is the model of the workflow that you're building. And so I'm sort of just giving it that chance to kind of show its stuff with a much more complicated example. And this works 1 time out of 10 with the Llama 3.1 model. If you use OpenAI, it'll work fine. But if you try it with the Llama models, sometimes it'll work, sometimes it won't. This is just I took this, for example, from another thing where it's scraping the Boston calendar and just pulling back 3 events that are happening today. I'm not going to go through beautiful soup code. I'm just not going to do that right now. But the main thing I wanted to call out is essentially saying I want a structured output, which is going to be the date and a list of events. I'm going to pass you as a dependency a string, which is going to be the today's date. And then it's going to expect that as part of the dependency in the tool, which is somewhere. Yeah, right. I make this an argument where it expects to get the run context, and from that run context, it's going to get the date. And so, I mean, I can run this. It'll fail, probably. Oh, well, let's roll the dice. Let's see if it works this time. But this is just to sort of show off like what Pydantic, their documentation sort of recommend. You're doing more of this sort of stuff where you're saying what are your expectations on either the inputs or the outputs, and specifying some kind of dependency that the model should be passing or the agent should be passing to itself. Probably this is not going to work. It takes a little bit of time. We'll come back to it. Great. Anything like different with Pydantic.AI? Anything that like you feel is more of a strength, more of a weaknesses? Anything that you're seeing?
Way more complicated and more brittle if you didn't do something right.
Yeah, I'd say complicated for sure. I think brittleness, it depends on like what you're, like brittleness for like debugging, I think yes, but brittleness in terms of like if you have expectations that you want to enforce, you have a little bit more of the, or it's designed around that capability.
Brittle in the sense you're not like familiar with the documentation, then it takes time to figure it out.
Yeah, if you're not familiar with Pydantic as a library itself, it takes that time.
Their output was more descriptive. I noticed a lot of details in the output that I wasn't seeing in the other ones.
That's a really good call out, actually. I didn't even think about that, but that's, yeah, it failed. So yeah, that's actually really a good call. Yeah, so it implements, like their classes are different, and it implements like what the steps are in a different way, even though some of the setup looks the same. That's a good call out, yeah.
It's only Pydantic.AI, right? Only one dependency.
Yes,
Okay.
thank you. Teed that up. So great, yeah, I think, again, complete, model agnostic. It has this built-in validation. You know, downside, again, control is abstracted. You've abstracted away a lot of the capability there. It recommends a pretty complex setup. You have to spend a lot of time like structuring this thing. It's not as like quick to demo. Fewer integrations, right? It's been around for a shorter amount of time. It has a smaller community. So these are all sort of the things that make it kind of sort of balance your decision, I guess. Oh, I realized I went really fast. Whatever, that's fine. So yeah, I tried to summarize, like this is my attempt at summarizing my explorations of these things, and welcome like thoughts on these things. But like abstraction has been the theme, right, that we've gone through. Like, do you want like very clear control over things? If you're trying to just like experiment, see what the model is returning for a particular input, then maybe you don't want to like jump into a framework that's going to build a bunch of stuff and then find it fails in this component or that component. Demoability versus deployability, like where are you in the life cycle? Do you want something that's quick to demo? Do you want to just like show off like what are the capabilities? Versus do you want something that's ready to go? Like you want to build something that's a service that's part of something else that you want it to be like reliable and things like that. Input out like a structure that you expect in terms of what you're going to be passing to it and what you expect out of it is a key component. Again, I'm not saying which like is doing this better, but like those are considerations and might lead you to use a particular framework for a particular step, a particular framework for a different step. And then I struggled with how to phrase this right, but like the mode of interaction, I'm thinking more like what I'm trying to get at here is like, if it has a lot of integrations, you might be able to build like a Gradio like front end on top of your agent or something like that. And it's a lot more easy. There's a whole community around that. There's a bunch of like conversations people have struggled with this and have examples to work from. But if you're building essentially a fast API, but it's an agent, then maybe like Pydantic has a little bit more advantage there. But it also depends, like what do you require? What integrations do you require? Not that LangChain is just the integration king, right? And that was likely to change over time. Fantastic. And my recommendation here is like my recommendation all of the time. I feel like I'm like kind of old school. I'm like feeling like old school like data scientist, where I'm just like like what is the minimum, like what do you actually need? Like what is the minimum version of what like will solve your problem before you start jumping into the latest and greatest and most exciting thing. Because the latest and greatest and most exciting thing is built on a lot of those like underlying components. And if any of those components fail, then it's harder to debug versus if you have a smaller component. And I think I'm just echoing like other speakers, pointing them out in the crowd, saying essentially the same thing, but like I tried to frame this in terms of like paths, in terms of like the particular like ways you expect a user to kind of like walk through your application. In a search, you're essentially like just expecting people to put in a search query, and that search query will then be compared against your documents, and you'll return some set of documents based on whatever algorithm. And you know you can pose some structure on that output, and you know what the use case is. In this case, you don't need, like, you probably don't even need an LLM, except maybe if you're using an LLM for like creating the representations. Search exists and is powerful and has powered at least one major company. Question answering is a little bit more, I'm calling it kind of single path because you know what people are coming to it for. They're asking a question, they expect an answer out of that, and you have resources that it can search and pull from. Essentially, all you want to kind of do is put a layer over search where it kind of like summarizes like what are the things that are returned. When you get into, like, for example, like question answering with code execution, maybe it answers the question and executes code, maybe it just answers the question. There's a bunch of different pathways that start branching, even though it's not like every possible path, it's like a sort of constrained set of things. You still know what people are coming to it for, and you still know like what the workflows, like have some rough idea of what the possible workflows might be. And the output is still unstructured. And so you might just do an LLM-based workflow with this sort of thing because you sort of know what the steps are, or at least like if you have two different ones, it either executes code or it doesn't execute code. You can code that in. An agent, then you might want to trust the agent to like decide what is the right pathway to go down. So that's a kind of like maybe thing. When you start getting into conversational stuff, like that's when you're like, the number of possible like avenues that your user interaction can take explodes, and that adds complexity. Like I'm not going to dive into that too much. That's a hard problem to solve, and it's not necessarily a solved problem. But that's where agents are a little bit like kind of shine in their ability to decide what of those pathways and introduce new novel pathways and sort of guide maybe the user back to where they need to be. This is my like rough framing of it. I'm not necessarily 100% on like that's the best way to frame it, but yeah, that's it. Other interesting frameworks and libraries. If you want some bespoke Boston local agent frameworks, LlamaBot is pretty cool. If you have any questions or complaints about it, I know a guy you can talk to. Hugging Face is cool and has small agents, and it's very, very simple. Malia, I heard about 2 days ago, and is pretty cool if anybody went to that talk. That seems like that's going to be an exciting thing to watch. I have a bunch of stuff. You can get in touch with me. Hey, anybody Boston local? Hands raised. Are you part of the Boston meetup for Python or for PyData?
Yes.
Oh, there's 2 people out of a lot of people. I think all the rest of those people should come talk to us and hang out with us. We have pizza. Cool, and that's it. And I'll take any questions.
Thank you, Ben. We have 5 minutes for questions. I'm sure others learned a lot about Pydantic and many things. I love this because I'm familiar with LangChain. I would love to hear all of you who are familiar with one and now learned about another. Maybe Ben will encourage you to shift. Who's got a question?
I heard a lot of questions of what we think about these things, but what do you think?
Yeah, I don't know if I've like, I think that's why I didn't try to like sum up and say what's the best framework, because I don't know if I have an answer. I think it depends. Like I think LangChain is really cool because it's like, there's a whole community. If you want to like build a particular like demo for something and see if it works, like there's probably 5 people that have done the same thing before, and you can sort of learn from their mistakes, or sorry, their successes. But Pydantic, I like the idea of like imposing structure and like at least starting from that, right? Like having the unconstrained possible like world of all the different user interactions, like expecting your application to handle that first out of the gate seems like problematic. And so imposing some amount of structure or constraining the possible like space seems important. So sorry, that wasn't an answer to your question. I think they both offer something. Yeah.
I'll ask a question. In your experience of seeing things in production, have you found some of these pitfalls in production, or can you speak about a production use case at all?
Yeah, I mean, mainly with production, I think it's like you're sort of sometimes tied to a particular framework. So for example, my company, a lot of the stuff is in Databricks. Databricks has its own implementation that pulls a lot on LangChain. So yeah, like kind of a boring answer to that question, that like sometimes you can only use a set of things. Interestingly, with that Pydantic example that I had before, if I passed it the date as a dependency and asked it to get the list of events, it will work occasionally. With LangChain, it won't. LangChain, for whatever reason, it has a bunch of different things that are happening in the background that make it a little bit complicated for a small model to do. So that's another thing to consider, like the size of your model. Thank you for like teeing that up, because I'm using a Llama 3.1, which is a 7 billion parameter model. It can't do a lot. So if you don't have access to like regular calls of OpenAI or something like that, or if you want to just explore local things, that's when you start thinking about like what is the framework or library that can best like fit that use.
Hi, your talk was really great, and I would like to ask a question. Like, how does Ollama handles the CPU and GPU scheduling? You can just say
Oh, Llama?
Ollama, yeah.
Actually, I'm not 100% sure. Yeah, I've used Llama mainly for like teaching examples and for experimentation on a local things.
Is there any time you faced any difficulties while using Ollama?
Yeah, I mean, there's like limitations on if you're running it on your local machine, it's whatever your local machine can handle. So basically the max that my M1 machine can handle is like 8 billion parameter model. Beyond that, it just like chokes a little bit. So that's the constraint. Like that's at least the main constraint I've run into. But
How does the Pydantic.AI handles a large amount of data, and what kind of latency issues you faced in your real-time work?
that's a really good call out. As you impose more structure, at least that I've experienced, is that it will be more likely the model will like violate that structure, and then it'll be like fail and like come back and try again, or it'll depending on how it's like constraining the decoding, it might take a long time for it to output something. So if you have a lot of like complex requirements on it, it might take it might be a higher latency in terms of like getting your response back. But yeah, thanks for asking that question.
I know there's other frameworks, or a number of other frameworks, and I'm just curious why you might not have mentioned those or chose those other ones.
You're pointing out my bias here. Like, so I like the OpenAI SDK is really cool. Has a really lot of features. I didn't really have the time to explore it, but also I prefer an open source framework versus. I mean, not that the SDK is not open source, but the libraries it interacts with are not, and so that is my main reason. But there's probably a bunch of other things. Like something like Crew AI is something that a lot of people have mentioned, but that's multi-agent, and I don't know. I already got a headache from going into this. I didn't want to get into multi-agent stuff. Yeah.
Thank you.
I'm going to ask kind of like the same question I asked this gentleman yesterday. How do you position like model context protocol in this type of building of tools of agents that call tools?
Yeah, that's a great question. And yeah, I mean, I think it's just like the tools that are like as far as like my thoughts on MCP is it's just like here are the it's a nice way of standardizing the actions that are available to the model. So like yeah, I like it because standardization is a good thing in this, and particularly in this context. But yeah, I mean, in terms of how does it interact with LangChain versus Pydantic, I haven't had enough experience with like each of them to say like one is like has a better accommodation for the other, but they both like have functionality built around that. But actually, Sebastian's a good person to talk to
Yeah.
because one of his talks at PyData Boston, he had sort of talked about like constraining what tools, what sort of actions you make available, and like thinking about the right way to do that.
I'm assuming maybe Pydantic would deal better with like remote MCPs because of the async nature. I don't know. I'm assuming, but I haven't had lots of experience with that.
That's a
so
good
I was
call out.
interested.
Yeah, I mean, I would agree. And also just being able to like manage what's calling the like where is the client that is calling the server. I think Pydantic is more designed around that. So yeah, thank you. Sort of answered your own question, but yeah.
Thank you so much, Ben. We have this room for 35 minutes, but this is the end of this scheduled programming. So I wanted to give Ben one more round of applause.